Hey guys, so this is video 2, technically video 5, all in total of our exponent properties notes. So this is video 2 for Tuesday. We're going to go ahead and get started on property 5. So this is still on page 32 in your notebooks, okay? Property 5 is our negative power rule, all right? So think about, again, the word power just means an exponent. So for all of these, we're talking about negative exponents. All right, this is one of my favorite rules to teach because to me it makes the most sense. Well, it doesn't make sense to y'all, but then when I explain it the way I do, y'all are gonna be like, oh, okay. So negative exponents. In math, have you ever seen a negative exponent? I'm hoping you say no, and here's why. We cannot, I was going to say no, but we cannot have negative exponents in math. And I'm going to explain to you guys why, okay? If I say, let's use one of your classmates. So Janasia, don't be mad, I'm using you because you run track, okay? So Janasia is going to be this J. If I say to Janasia to go run 3 laps around the track, that would be like J cubed, right? Okay. If I tell her to go run 1 lap, that would be like J to the first, right? What if I said, Janasia, go run -2 laps? How you going to run a negative lap? You can't do that. Some of you are going to be like, oh, she could run it backwards. She's still running 2 laps. It's just backwards. That's not -2. If I tell you to run -2 laps, that'd be like time traveling backwards twice. Do we know how to time travel? No, not yet. Not a thing. Okay? So we can't have negative time. Just like if I said to you guys, all right, you have homework squared tonight. That means you have 2 homework assignments, right? If I said you have homework to the -4th, I'm going to take away 4 homework assignments. That's not how it works, right? So in math, we cannot have negative exponents because a negative exponent concludes that there's negative time. And we know this from when we were graphing that we can't have negative time. If I'm timing somebody to do something, it can't be negative, okay? So our negative power rule says this. If an exponent is negative, you must move the exponent, and this is important, its base, because you can't just have an exponent floating by itself. It's got to be attached to something. You must move the exponent and its base to the other side of the division bar. Okay? So I'm going to show you guys what this looks like. So for our negative power rule, if an exponent is negative, you must move it and its base to the other side of the division bar to make it turn positive. I knew I was leaving off something. All right. So if an exponent is negative, move the exponent and its base to the other side of the division bar and it will turn positive, okay? So I'm going to show you guys an example. So example 1, if we have x to the -3rd, okay? This one usually trips people up. So first of all, this is saying x happens -3 times. We know we can't have negative time, right? So this does not make any sense to us. But if I can move it to make it positive, we know what x cubed is, right? That means x times itself 3 times. We can't have x times itself negative 3 times. That doesn't make sense. So if an exponent is negative, here it is, you must move the exponent and its base to the other side of the division bar. Every year somebody says, well, Miss Poole, we don't have a division bar for this one. Yes, you do. Remember our rise over run. If there isn't a run, we always made it a understood 1. I'm like Busta Rhymes over here today, okay? So now, to make this positive, I'm going to move the exponent and its base to the other side. So since it's in the top, I'm going to move it to the bottom, all right? Which means in the denominator now, I'm going to have 1x and the 3 becomes positive. Okay? So when you move it to the other side, you're making it positive. All right? Now, what's understood in the top if there's nothing there? What do we put? An understood 1. Very good. Now, I know somebody's going to ask me this, so I'm going to go ahead and answer it. Do we have to have this 1 in front of the x? No, because it's understood. Do you have to have the 1 in the numerator? Yes, because there has to be something up there holding a place. Okay? So this is 1 over x cubed. And that's how you deal with negative exponents. I've got like 4 more examples for this one because I want to make sure y'all are good with this, because this is one of the biggest topics for Math 2 and Math 3, okay? All right, so let's do another one. I'm going to put it right here because I have a feeling I might run out of room. Negative 4x to the 5th, y to the negative 2nd. All right, so I only see 1 negative exponent. What about y'all? Now, every year I have somebody try to move this negative 4. Does the negative 4 have a negative exponent? Y'all, we know what negative 4 means. It means take away 4, right? It's the opposite of positive 4. It doesn't have a negative exponent. This 4 has an understood positive 1. So do we need to move the 4? No, do not move the 4. If somebody moves the 4, I'm going to be like, what are y'all doing? Okay. Which one of these bases has a negative exponent? Good. This one right here, right? The y to the negative 2nd. So we have to move that to the other side of the division bar to make it positive. Now, we don't have a division bar that we can see. Think about your slope, your rise over run. If there isn't a run, it's over an understood 1, right? I'm going to do this in pink so y'all aren't like, where did that come from? And now we're going to move this down here, and it should turn positive, right? So in the numerator, I still have negative 4x to the 5th. You can put the 1 with the 4, but you don't have to, okay? Remember, it's understood. And now in the denominator, I have 1, which I don't have to write, right? And then I have y to the positive 2nd now. So for this one, we're actually done now that we've moved that y to the negative 2nd and made it positive, because you can't combine x's and y's. I can't do x to the 5th divided by y squared. They don't have the same base. So that's how you would move that negative exponent, okay? All right, let's move to example 3. Let's do, this one's tricky. Let's do this one. X squared divided by y, all raised to the negative 3rd. Okay, so for this one, we have a negative exponent. Okay, we cannot have a negative exponent, so we normally, if it was just one thing, would move it to the other side of the division bar, right? This one is tricky, tricky, tricky. Put a big old star by this one. I'm just showing you this because when you get to Math 2, you'll see a lot like this, okay? So normally we would move it to the other side of the division bar, right? Well, let's do it this way first. I think y'all got this. Simplify the inside first. Remember me saying that up here? Can you do x squared divided by y? Is there anything to simplify? No. So this negative 3 that's out here, you guys know, goes into both of these exponents, right? So this is going to equal x to the negative 6th over y to the negative 3rd, because I'm multiplying both of my exponents by that negative 3 outside. This is your power raising rule right here. Now I have negative exponents, and what's tricky about this one, this is why there's a big star. Do y'all see how they're both negative? If they're both negative, that means we have to move the top one down here to the bottom to make it positive. And we've got to move this bottom one up to the top to make it positive. So this is going to be y to the 3rd over x to the 6th. This is your final answer for this one. Okay, we're not done with the negative power rule. I'm going to show you 2 more in the next video. I just ran out of time on this one. Please, please, please make sure that you check into the video office hours and you work some of these with me if this confused you, okay? But keep going on video 3. I'm about to post it right now.